when asked what food I was recommend to him, it is you are what you eat. Advanced communicator Aon speech this evening is cooked without fire. Please help me welcome him to the floor.
You never see smoke without fire. Even if you're hearing this proverb for the very first time, you couldn't consider me presumptuous, assuming that you understand the meaning of it literally and figuratively. Everyone knows that wherever you see smoke, there is fire. Isn't that so?
Not really, no.
Brother Toastmasters and guests. Good evening.
Good evening.
Before the end of World War II, if someone had said to you, you never see food cooked without fire, you might have interpreted that in a metaphoric sense, just like you never see smoke without fire. However, that statement today would incite scorn and ridicule and laughter, all because of Percy Spencer's accidental discovery of the microwave in the 1940s. According to the website lifescience.com, more than 90% of the homes in the USA have a microwave oven. This ubiquitous appliance cooks food by exposing it to electromagnetic radiation in the microwave radio frequency spectrum. This process really just rotates the molecules, the polar molecules in liquids of food at a rapid rate, so much that the friction creates enough heat and energy to cook the food. However, some people have concerns about the microwave rearranging the molecular structure of the food. There are questions about the integrity of the nutrients. But did you know that there is an alternative way to cook your food without fire and without those concerns?
Yeah.
Ladies and gentlemen, let me introduce you to the electromagnetic induction technology.
Okay, sir.
A way to cook your food without fire and without exposure to electromagnetic radiation. They sound alike, don't they? Electromagnetic radiation and electromagnetic induction. They're quite different. I will speak to the latter. Before I continue, I want to share some tidbits about magnetism and electromagnetism. Most of you are familiar with a magnet. As a boy growing up, I spent a lot of time playing with magnets. In fact, I still do. Now, one of the things I discovered, I'm sure pretty much most of you already are aware of, is magnets are attracted to steel. It's attracted to steel, and steel or iron is attracted to magnet. And here we have a pot which is magnetic. It's the stainless steel pot, as you can see the magnet is sticking there. But we also have metals that don't stick to magnet. This stainless steel pot doesn't stick, and you'll see how important that is later on. Another thing that you might not be aware of is that some metals that are not magnetic, like this copper wire, if you pass it through a magnetic field, it produces electricity. And this process is what is the principle that generates most of the electricity worldwide. The reverse is also true. If you pass electric current through a wire, it produces a magnetic field. And this magnetic field can be strong enough to attract iron and steel when the electricity is in there. That process is what you call electromagnetic induction. The process of transferring from electricity to magnetism. And this is the technology which this cooktop operates under. Under this glass surface is a huge coil of wire, and an alternating current passing through this wire can produce a strong magnetic field that can induce magnetism in the bottom of this pot, so strong that it can heat the pot up and cook your food. In fact, it is very advantageous because it doesn't waste energy. It doesn't have to heat the surface here and then heat the pot. It heats the pot directly. And so I'm going to demonstrate this for you today. I'm going to put a piece of paper towel on this stove, right here, and you put that on your electric stove and you turn it on, you're going to see smoke. You're going to see smoke without fire. And I'm going to rest 2 chopsticks here to lift the pot from off the surface so that when the pot gets hot, it doesn't heat the surface. So I can prove to you what. Can you see now?
Yeah.
Okay. So I'm going to start it. And while the pot is heating up, I'm going to introduce you to some of the features of this cooktop. There are 6 temperature settings here, 6 buttons, starting from a low of 100 degrees to 575 degrees Fahrenheit. In increments of 10, you can adjust the temperature with this plus and a minus sign. It also has a timer that can set the time to a maximum of 60 minutes. But with a program button here, you can set several increments of time to different temperatures. For example, suppose you're going to be cooking dumplings. You know you want to get the water hot quickly. You can put it on the highest for the first 2 minutes, and then you can set the next step to cook for about 375 degrees for about 3 minutes, and then you can simmer it down at 175 for the next minute. Now, my pot is supposed to be pretty hot now, and I'm going to prove to you that you can cook food or boil water, whatever, without fire. Here we go.
No, that's steam.
Are you convinced? This is pretty hot?
Yes.
Anybody have mint? You can have some tea. Okay, and guess what?
Wow.
Look at this.
That's fake.
I know cooking without fire is not strange to you because of the microwave. But I have demonstrated to you an alternate way to cook your food without fire using the induction cooktop and cookware. The main advantages: little or no loss of energy, heating energy, very fast, and it cooks your food without any exposure to electromagnetic radiation. Now, who said you never see smoke without fire?
Okay. How about the voice? I think that's work.